another stream right here, about 1 hour and 30 minutes length. We're doing the exact same thing as always. I've seen the Doctor Disrespect stream and add the nice animation in between the scenes, and when the game was loading there's like a concert screen, which was cool, but I don't think we should implement this right now, so we're just gonna do the normal stream. Anyway, we've got this minus 3 plus 5 I number, and we need to understand the value of the module of it. And the formula for the module is actually square root. So basically, the real part, the a number, we can say all to the second power, plus the imaginary part of the b number, all to the second power, all of that under the square root. So right here we're gonna have minus 3 to the second power plus 5i to the second power, all under the square root. And we know that I to the second power is minus 1, so we solve it and we get the appropriate result. But this guy right here, I've seen this exercise being done, and I think he missed one I, so the result should have been minus 3 plus 6i, but anyway, we're gonna see what we get here, and we're gonna work with that. So basically the formula of a module is being written, that's how it's done with the symbols, and that's that. Okay, so we've got that. So now we got the two numbers, A and B, like I said. And so we will have 9 plus 25. And actually we ignore the I. Looks like I thought that we work with it, but looks like we don't. So square root of 34. So now he will understand that he messed up, right? Because there should have been 9 plus 36, right? And that would have been square root of 45, and you can write that down as 3 square root of 5. But anyways, let's see if he spots the mistake. So you can see when it's written with a black and then the underlines, that's where he missed minus I, which made a difference here. So this will be placed right here, and this will be corrected right here. Okay, so we're done, right? Minus 3 plus 4i, because it's a minus I. Okay, in which case we'll get 9 plus 16, which is even better, because we get square root of 25, which is a perfect square, so it's just a 5. So that's that. We've got that all done in the best way. Now for this exercise, we got z with a line on top, which is the conjugate of z, which is just the primitive form, you know, a plus bi, that's the normal z, and with a line on top, you just change the sign, which is going to be a minus bi with a line on top, the conjugate. So you got the conjugate, but you need to understand the normal one, so you just flip the sign. So first of all, you don't get just the normal conjugate, you get a complex version, so you're going to work with a parenthesis, multiply each term, and where you get out the second power, swap it with minus I, and it should work out pretty easily. No issues right here. Okay, so we got that. 1 times 2, that's just 2. So right here, the explanation is done, and now we can move on with the calculation, right? Yeah, I think we can move with the calculation. The exercise being written, and now we're gonna move if it's. And actually, this video is lagging a bit, but anyways, I'm skipping, and it's all clear. The quality is fine, so it should not bother as much. So 2 plus I, each term multiplied, and then plus 2i, and then plus I to the second power, and then you just write down minus 2 minus 5i, what's left there. And y to the second power gets written as minus 1. And now we have basically minus 1 and minus 2i, right? Okay, so actually what plus 2i? Okay, so yeah, the conjugate is that, and the normal one with a sign flipped is that. So we have successfully understood what is the z, which we had to do in this exercise. So we are gonna write that down in the response. Okay, so here we have to understand the module of this right here. And previously I've listed the formula of module. A to the second power plus b to the second power under square root. A is the real part, b is the imaginary part. So as you can see, this is all in fractions, so we have to get the normal form. So we multiply with the conjugate, I think. So the conjugate, you know what's that? It's just the sign changed of the bottom part. So we're gonna multiply everything with a 3 plus 4i, and I to the second power swap with minus I. That's all it is. So that's being written out, and the multiplication with the conjugate is being displayed here. There we go. And now we have this, parentheses and stuff, and that. Okay. Now, on top we don't have any formula, but below we have that formula, a to the second power minus b to the second power. So it's going to be 3 to the second power minus 4i all to the second power, which is 9 plus 16, because you have 4 to the second power by 16 with a minus up front, right? But I to the second power, it's going to fill up a sign, so 25 below. And on top we're going to have to multiply by term. So 12 times 3, that is 36, and then plus 48i, and then plus 27i, and plus 36i to the second power. So that's the initial result. Okay, so 25 we have below, which is correct. And now what we have above, basically you see the minus will flip a sign in front of a 36, so we also have a positive 36 at the beginning, so we're gonna get reduced the positive 36 with a negative 36, so all that's left is 48i plus 27i, which is just 68, and then with a 7, 75i. So we're gonna have 75i divided by 25, which is 3I. So looks like we only have imaginary part, and as we know, we have to calculate the volume, in which case we also need real part, but real part is not present, so just 0. So we're gonna plug it in as 0 to the second power and work from there, right? I think it's gonna be like that. Okay, so we have this, that, right there, and then minus 36 right there. And equal right there. And we got that. So 0 to the second power, that's just nothing, right? And that right there is going to be 3I to the second power, all under the square root. And actually 3I to the all to the second power under the square root, so it's just gonna be 3I, right? The module, as far as I know. So, oh, we actually don't, I forgot again, in the module we don't work with I, so we're just gonna have square root of 9, which is 3, and that's that right here in the module. So there we go. Okay, so we have a z number. Find the module of a complex number, and what else is written there? So once again, the conjugate of this number, just with line on top, it's with a middle sign change, so it's going to be minus I minus 2I. And I have to see the whole condition, I did not read it. So there it is. Let me see, come on, let me see the whole condition. Find that module. So basically we have this W. Find the module of complex number this, where Z, line on top, is the conjugate. So basically you have to calculate this W, which is like a more complex form of a Z. It encompasses both a Z and the zero line on top. So we're gonna have to calculate the W and then extract the A and B and calculate module like that. Okay, so we're gonna write it down right here. And instead of a Z, just write what you have in Z, and with Z on the line on top, I to the second power is minus 1 as we know. And then the formula of module, I'm just gonna recite it when we get to it. So we write down this right here, and then plus 2 right here with a Z with a line on top. You write down that in the parentheses as a whole, and you have to multiply each term properly. There we go, exactly like that. So with arrows displayed right here, the blue arrows, you can see how you have to multiply. So you're gonna have minus 5I and then plus 10I to the second power, and on the second thing you're gonna have minus 2 minus 4i, and work with the numbers right there. Okay, that. Now this. Okay, so we have 10i to the second power, so that's just gonna flip a sign. Minus 10 is gonna be, and to work with minus 2 minus 12, and there we have the I terms, which will be minus 9i. So that's that. Minus 12 minus 9i. Now we have to get the module of that, which is a to the second power plus b to the second power, all in the square root. So a is 12, b is 9. We'll have 144, but a plus 81, all under the square root. And you don't even need to take a look at the minus right there, because any number at the second power gets basically positive, and yeah, doesn't even matter here. So it's going to be written out right here. Minus 12 minus 9, that's 144 plus 81. And how much is that? That is 200, obviously, and 25, which is, when we take the root of it, 15, right? Okay, so we got 15, and that is our response right here. And congratulations, I have finished this video. I'm quite good at this modules and stuff, Z numbers. Okay, so now I'm just gonna find another video. I don't need to go to pause mode right now. So Bible Dragish, thank him, he got this video. Now we're gonna go with Daniel Prazerovsky for this video right here. Open a new window, and it's just gonna be a wider range of exercises. First 10 exercises at the test. Okay. Clutch new racing game. Check that out. State of play tonight. Mostly just PlayStation IP games I really care about. So these are the news. Anyway, unfortunately we're doing math, so we're gonna have to focus on that. Which one's gonna do first? So this is basically mathematical analysis, which I don't really get into. We're gonna have to take a look at someone else for this. Okay, so first one, right? Find value of this expression right here. Come on, where is gonna start it? 5 minutes, 6 minutes in the live and still thinking about it. I started my live, boom, flash, straight in, effing prepared, like come on. Okay, so this is like an explanation right here. Essentially 625 is just 5 to the 4th power. That's correct, because 5 times 5, 25, times 5, that's 125, 125 times 5, 625. So that's correct. So basically we're trying to remove a 5 in front of the square root, and we have received something like this: 5 in front of the square root, or I don't know, square root 5 fifth order, I know it's called. And then we have 5 at fourth power right there, and we cannot quite extract it because we could have just removed square root if it was 5 of a fifth power, which is not. And I don't know, in this case I can just write it down as 5 to the second power, which is 25. Yeah, I don't really know here. Now, if I take a look below the fraction, I see 25 of the power of minus 1 divided by 10. So 25, that's obviously 5 power of 2. And when I transferred that power of 2 to the right, it's going to be minus 2 divided by 10. And that will be simplified minus 1 divided by 5. And basically we can work with that power. We got the 5 base and minus 1 divided by 5 of the power, which is minus 5 of the power of minus 1 right there of the power. And then you take the minus to the basically the power is going to be 5, so 5 of the power of 5 right there, right below. I think that's what's going to be right there. So let's see how it is here. We just need to simplify this expression till the end. Okay, so this is how it is possible. Okay, so think about it. So this guy actually gave me an idea. So basically right here is working with expression below 25, right? And what he did, he basically split that fraction into that. The minus 1 divided by 10 fraction he wrote down as 1 divided by 2 times 1 divided by 5 negative, which when you multiply is going to give you minus 1 inverse divided by 10 basically. So I think he wrote that down as 1 divided by 2, that's just square root of 25, and that's 5, so we got the same power. So pretty much it's just another method. And he gave me this idea that on top of a 5 right there in front of square root, you can write it down as 625 at the power of 1 divided by 5, right? And you have 5 power 4, so you're gonna have essentially the 4 at the power times 1 divided by 5, so you will have on top 5 at the power of 4 divided by 5, and then you can kind of work with what's below. If you divide, use the power properties, stuff like that, we're gonna see how it is. This one is like the harder stuff right here. Usually it's not that hard in this exercises. Okay, so we got this. So we got this, right? Okay, so I think he prefers to write the power as minus 1 divided by 5 and keep it like that below. The parentheses, by the way, is not necessary. Intended to do this as when we'll do the division between the term on top and the term below. It's going to be 5 with the same, so basically the same base, 5 with the power right there at a fraction above, and then 5 at a fraction power also then below. So then we can work with the powers, and I think we'll have like a property right here. So basically, if we have two numbers with the same base with some powers and they're divided, then basically we have to do minus with the powers and keep the same base, and we're gonna keep it like that. So it's gonna be 5 add the power of 4 divided by 5 minus 1 divided by 5. So that is going to be 5 at the power of 5 divided by 5, which is 1. So that's it, that's 5. So that's the whole exercise right here. I remember that property right here. So it's being written out, of course it is being written out. Okay, so he decided to, I don't know why he decided that. Everybody got his own methods. So basically we have essentially 5 of the power of minus 1 divided by 5 is that. It's basically 1 divided by that. Why? Because it's minus 1 negative power, so 1 divided by that, and then we have 1 divided by 5, so that's like 5 with a square root up front like that. So yeah, that's that. And whatever method is going to use. That's right, that, like that. So if it's times, it's going to get flipped, right? So it's going to be 5 up front of a square root and 5 to the power 4 times exactly like that, but only with 5 under the square root. Okay, I get that. And what's this? Yeah, camera cutoff is not that great here. So we have this. Essentially, this property is being used here. When you multiply scores like that, you just get this, and so it's gonna be 5 to the power 5, and then it's gonna be 5. Okay, so you can also use this method, but I think my method is slightly better, as I didn't really know this property with square roots that you can multiply like this essentially. So that's just 5. We're gonna move towards the next exercise now. So complex number exercise. We got the z. You gotta understand the module of a complex number. So essentially, formula of module, I'm gonna say it at the end, so we're just gonna have to solve the z. get it to the simplest form, and we have a second power right there. We can work with that. It's essentially going to be 7 plus 3i with a formula. So 7 second power plus 2 times 7 times 3i plus 3i all to the second power, and then we have 33i to the 7th power, and I to the 7th power, that's just I to the 6th power times I, and I to the 6th power, that's just minus 1. Why? Because I to the 2nd power is minus 1. So that's minus 1 times 3, that's just minus... not minus 1 times 3, it's just going to be minus 1 times minus 1, which is 1. And then 1 times minus 1, that's minus 1. So that's just going to be minus I right there. So 33 times minus I, which is minus 33i. So that's how I think, like, before everything's being solved, because that's efficient, I think. And so first we apply formula 42i. Why? Because just 2 times 7, that's 14, and times 3, that is 42. And we have I right there, and plus 9i to the 2nd power, which is just minus 9 if we just relocate the I to the 2nd power of minus 1, and then we'll write that down. So now I to the 7th power is being written out. So we have this minus 9 right there. So 49 minus 9, that's going to be 40 right there. And that's right there. So 42i minus 33i, that's just, how much? 9? No, it's not 9. How much is it? It's just... Actually, it's 9, right? Yeah. It's, 9i. So 40 minus 9i. Well, plus 9i. Yeah, sorry. Because of a positive, it's bigger. Okay, so we got this. Now module a to the 2nd power plus b to the 2nd power, all under the square root. And essentially 40 to the 2nd power, how much is that? That's 1600, and then plus the b, which is 9. So basically the imaginary number without the I. 9 to the 2nd power is 81. So in total we have 1681 all to the square root, which is, I don't know how much. Might be something like 42, or I don't know. So module formula right here. And so we work from here. Okay, so come on, stop explaining. I'm explaining right here. Yes, excellent. So what number at... So 1500, does that have like some number at the 2nd power that gives 1500? I don't know. 30 at the 2nd power, that's just 900, right? So that's that. 1681 square root of that. Perhaps there's some trick to do it. I really know. Square root of 1681. Maybe it's done like this, like, I don't know, maybe this is like a genius way that's already been invented. Basically, 81 square root of that's 9, and square root of 16 that's 4, and when you put them together that's 49. I'll be pretty amazed if it's actually 49. Okay, so it's 41. Okay, so I think I said something like 41, so I'm still pretty genius, but anyways, it's 41. Which kind of makes sense because 40 times 40, it's 1600, right? I think. And so you add one more, it's gonna be that for some reason. So, now we have this matrix right here with LOGs and stuff. So first of all, I was gonna write it down. How'd you solve it? So basically, all this matrix is equal to 0, and multiply diagonally minus the other multiplication diagonally, and then use some properties like with the same base of algorithm, logarithm, which will be shown. Yeah. So here we go. Here we go. 2 log 3, 5 minus x right here, minus that right there. Okay, so we've got that. I mean, at a test, I don't know what's up with your test, but on my test, there is a sheet with some formulas you can use, and I got the log formulas right here. So right here we do have the same base, right? The log 3, and I think we can just work with stuff with the parentheses right there, but we do have a 2 up front, which we can take and pop as a power of 5 minus x all in the parentheses. Should we actually do that? Maybe. And then once we've done that, we can just do the minus with the second part, right? So let me see. Well, the specific formula is not displayed here. I think it's done like that. It might actually be that the 5 minus x is divided by the x plus 1, stuff like that. I think the formula works like this. But we do remember that our 5 minus x is all to the second power, which also has a formula. If we take that 2, which we have to take in order to do the formula right here. Yeah, I think it's like that. 5 minus x right here. Okay, so minus right there. All equal with 0. Okay, so perhaps it's done like this. But the fact that it's equal to 0 does not help me much, right? I can move that log 3x plus 1 to the right, but that is not beneficial to me, is it? I don't know what this guy is gonna do. He has sometimes slightly different approaches. So basically that's the formula which I was talking about, which was not even my sheet. I just remember it from solving some of the stuff from before. So that's that. Okay. And that is also like some formula that I remember. So we pop second power right there, and we have that right there. And now, what? We're just gonna apply the formula, right? Not yet. We're just gonna work with that formula, and all of that equal to 0. Okay, so now we were gonna work with that. So pretty much we have this log right here. Why is he saying equal for an log? So he has the 0 to the right, but he's saying equal with log. I mean, how can you write down the 0 as an log? I think log of base of 1 and then 1 of the power of 0, stuff like that. Or log base 3 at the power of, so log base 3 and 3 at the power of 0, that can be written out. And then we will have essentially that 5 minus x all to the second power divided by x plus 1 equal to 0 according to the property, because we have the log with the same base. So yeah, perhaps I could have thought of that, but first I think I would solve that expression right there. 5 minus x all to the second power divided by x plus 1. Okay, so we got that. Why just 1? Why 1? Are you kidding me? I mean, yes, 3 over power of 0 is 1, but do you actually have to write down as 1? Like, all of that is equal to 1, huh? Okay, so this is some pretty much geek level stuff. Okay, so if it's geek level stuff, let's see how it is. So we got that equal to 1, and right here, that's 1 on the right, we can write down as 1 divided by 1, which is 1, so we can multiply diagonally, so we're gonna get 5 minus x to the all to the second power is equal with x plus 1, and so we're gonna solve that, and we're gonna get some quadratic, maybe, and we're gonna get our solutions, huh? Perhaps that. So let's get this done in the best way. X plus 1 right there. Okay, so come on, we're working with DVA now. I thought we are gonna go with matrix now. We're getting into some equation stuff. Okay, I mean, I kind of expected that, but I said I'm not really an expert into this geek stuff, so according to me, we have this fraction, right? So that's the reason for DVA. When you divide something, you cannot divide it by 0, right? So I think we have to say that x plus 1 is bigger than 0, and so our DVA will be that x is bigger than -1, right? So it's going to be from -1 till plus infinite with a normal parenthesis. So it's going to be that interval, right? I guess so. Am I right? I don't fucking know this stuff, man. 5 minus x also has to be bigger than 0. What is this absolute geek stuff, man? Like absolute geek stuff right here. Anyways, it has to be that. It's that. So that right there is going to be minus x bigger than -5. Switch the sign, it's going to be x smaller than 5. So then you intersect the GVAs and you get the appropriate interval, exactly what you need. Okay, so let's see how it is. So what's his writing? I don't see anything. Okay, so essentially my genius intervals that I calculated with my mind. We got that. I can even calculate with my mind what will be the final interval. So it has to be basically the x is smaller than 5 but bigger than -1, so the interval is between -1 and 5. Easy as cake. So what he will do is move a -1 to the left, equal that to 0. In order to have a common denominator, everything is multiplied with x plus 1. Okay, I do get that. And now what? Everything is multiplied with x plus 1 in terms of a 1. And come on, why use this method? Why can't you just crisscross it? Anyway, we got this. And what are you circling? Is there some kind of property here? I mean, there's a minus x plus 1, right? And so the minus up front of a parenthesis, this means we flip a sign of everything. We're gonna have minus x minus 1, right? Okay, so actually another geek interpretation. We just completely ignore the x plus 1 below and we work with only what's on top. Bruv. Like, come on, man. Anyway, let's use a formula and so on. So basically, formula, if a number is a minus b all to the second power, it's going to be a to the second power minus 2ab plus b to the second power. So 25 minus 10x plus x to the second power minus x minus 1 equal with 0. We have received this result right here. X to the second power right there. Okay. And so minus x with minus 10x, that is minus 11x. And then 25 minus 1, that is plus 24. So obviously we have received a quadratic interpretation right here. Solving for delta now. I mean, solving for x obviously, but just with delta now. So 121 is basically minus 11 to the second power. If it's second power, the negative sign disappears. Then we have minus 4 times a, which is 1, so 4 times 24, that is 96. And so 121 minus 96, how much is that? That's 25. So, square root of that, that's just 5. Okay, so now for first x minus b, so it's 11 minus square root of delta. We have minus 5 divided by 2. And now what? Now we have, after this, the second x, 11 plus 5 divided by 2, so that is 16 divided by 2 is 8, and then the first one, 11 minus 5, that is 6 divided by 2, 3. So 3 will go within that interval, 8 will not because it's bigger than 5, which is not within our interval. Okay, so basically the solution is 3. So pay attention to the intervals, and that's it. So right. Come on. Come on. Yes, not of a DVA. And so on. So just displaying the DVA graph, which I've already mastered. Okay, so onto this exercise with polynomials. We have to decompose in reducible factors with polynom, knowing that x equal of 2 is a double root of a polynom. Bruv, that's a bit of medium high level difficulty polynom exercise. I don't even see the polynom properly because of a camera, but anyways, we're gonna get it all set up pretty soon. So essentially, if x equal of 2 is a double root of a polynom, I'm not really sure what to do here. Should we just essentially plug in 2 instead of x, and then we're gonna have to get some factors like that? We're gonna see. I don't think we're gonna have to divide this whole polynom by something. I'm gonna see here. Not really sure. So basically this is the polynomial right here. And looks like we actually have to divide it with something. Yeah, this polynomial division, I rehearsed it not so long ago. I think I can clock it quite good. Yeah, like a ninja. X is 2, so by what we fucking divided? So I think we just divided by x minus 1. That's usually what we divide with, x minus 2. Okay, so why x minus 2? Because we want, I guess, to, so we have that x equal 2 is the double square, double root of a polynomial, so we have to just get it equal to 0, so we're gonna move 2 to the left. It's gonna be x minus 2, so that's why we we divide like this. I guess that kind of makes sense, but I did go over polynomial division with x minus 2 before, so that's kind of a number that makes sense here. So we have this. Now, first of all, what you need to do with this kind of division is just take a look at the first term to the left, which is x to the 4th power, and then you have to divide that with the first term to the right, which you're dividing with, which is x minus 2. The first one is x, the first term right there. So x to the 4th power divided by x, that's just x to the 3rd power, and you write that down in the results box. And now what you got, x to the 3rd power, you multiply with the thing that you're dividing. So that's x minus 2, so multiply term by term like that, and try to result to the left. So you're gonna have to essentially write down the x with a power below the x with that exact same power, and if that power is not available, you have to put the 0 on the power. That's just some more geek stuff that I remember. And then you do the minus and so on. So basically I'd have x to the 3rd power below there in the results box, so I'd have x to the 3rd power times x, which is x to the 4th power right down below the x to the 4th power of that to the left. And so x to the 3rd power times minus 2, that'll be minus 2x to the 3rd power, write it down below minus 8 times x to the 3rd power. And after that we do minus between the terms that are above and below. So essentially we're gonna have x to the 4th power minus x to the 4th power, which is nothing, and then minus 8x to the 3rd power minus 2x to the 3rd power, which is just gonna be minus 6x to the 3rd power. Then you bring everything down and you do like the exact same thing, right? Just gonna have to write it down. This guy is writing it down for me. All credit is due. I'm just like commentating this professional videos for my own perception and for potential online publicity. So that's written out. 0.8 there, we don't even write it. And now we bring everything down and we do exactly the same thing, bruv. All over again. We just have to bring down the second term. The other terms we don't really need right now. So minus 6x to the 3rd power divided by x, how much that is going to be? That's going to be minus 6 x to the second power. That's what's gonna be. So write that down in the results box. Now multiply everything term by term, where you're just gonna have minus 6x to the third power right there, and then minus 12x to the second power. And so you will have right there quite some intricate stuff. So essentially, hold up. He put the plus right there because he put the minus. I think he does the sign change or what. So we got 0 right there, and right there we have, hold up. Okay, sign change. And yeah, good. Now bring that below. 3x to the second power divided by x, that's just going to be 3x, so plus 3x right there. And minus 3x to the second power right there. With a sign change. I mean, it's up to you if you want to do this method, sign change, or just minus yourself. And then plus 6x right there, right? Plus 10x or what? Why? Okay, so plus 6x, so below we have 10x minus 20. So we have 10x divided by x, which is 10, so plus 10. We're gonna have minus 10x, and then essentially 10 times minus 2, that's minus 20. Sign change, we're gonna put plus 20, so we got 0. So this is exactly what we have after we have completed the division. And I think we need to write it down like as factors, this thing, the x to the third power minus 6, x to the second power plus 3x plus 10. What I mean by that is, I think we need to divide this again by x minus 2 so that we get a quadratic, so that we can solve a quadratic, so that we can plug in the x minus 2 at first of the parentheses, so that we can just do the x minus x to the third one, first one solution, then times the parentheses x minus the x second solution. I think we're gonna write that down. So I'm speaking really fast because there's like really much to do and whatever, and I think it's gonna be like that. Like, Jesus, man. Again, bro, if you get this type of test, it's gonna take you like 25 minutes to do it, or 20 minutes if you're like average. If you're Einstein, it's gonna take like 10 minutes. Anyways, so it's really, really big exercise. It's not that hard, but it's big. So we're doing exactly the same thing here. Of course, exactly the same thing here. Anyway, x to the third power divided by x to the second power, multiply everything. So this part will be easier because we're working with less terms as opposed to the polynomial division, which we just did. So we're gonna have x to the third power right there, minus sign change, and then plus 2x to the second power. So we will have minus 4x to the second power plus 3x, and then we will have minus 4x, and then plus 4x to the second power, and then minus 8x, right? And then we will have minus 5x, and then plus 10 below, and then we will have minus 5, And then we will have minus 10, so we got that. Now we solve that quadratic. Jesus, man, this is so boring. X minus 2. Why x minus 2 twice like that? X minus 2 twice like that. And then just that. Huh? Why? I think I would have to research this. Are we done here? Okay, so we can write down. But what is this? We write down the minus 4x as x to the second power minus 5x plus x. I mean, we can do that, but why? We can split it like that and factorize. So we will get this. And then we'll get x minus 5 and x plus 1. Okay, so basically, this is a really geek way to solve this quadratic and get this stuff, basically the solutions. Jesus, man, this is really geek. Anyway, you write down the geek result. And that's it, right? Congratulations, you're a geek if you know how to do that. So, what now? With geometry? Bruv, solves with a delta to show that his formula is correct. I told you, it's just a geek way to solve without the delta. 16, good, good. 36, bang. So he'll get minus 1 and then 5. So basically what he got. So basically, he is correct. Of course he is correct, bruv. So, now the geometry one. I wanted to see what he has written down, his formula, like the first thing right there. When he started just. So, x minus 2, x minus 2 once again. That's the form. Is there some logic to this? Is there actually some logic to this? Why x minus 2 twice like that? Maybe I can research that just to see. Yeah, B or B. So it actually was that in the previous one, double x equal to was the double root of a polynomial, so that's why it was x minus 2 twice, because you move 2 to the left and then you solve like that. Anyway, back to this geometry problem right here. So we have this triangle ABC, right? And the AB is 10, BC is 8, AC is 16, MN is like the line in the middle. We have to try and understand the perimeter of triangle AMBN. So, bruv, here we have like triangles that are kind of the same, and then we solve based on some relations. So man is like the middle one, so this means that it's half of AC, which we have, so it's going to be 8, so we got MN. To understand the perimeter of MBN, we need MB plus BN plus MN. MN we have. We just have to understand what's MB and what is BN. We do know AB and we do know BC, so I think we need to just do the usual MB divided by AB is the same as BN divided by BC, so we do that. We put, instead of MB, I think X or something like that. And we'll see. And I think it's also equal with the relation MN equal divided by AC, stuff like that. Anyways, we'll see. So anyways, MN is 8 centimeters right here. So MN is 8 centimeters right here. Triangle ABC is kind of the same as triangle MBN. MN divided by AC is equal with MB divided by AB. So yeah, my relation, my super G relation. Okay, so and then after this relation, I think we can do the Pythagorean theorem stuff to get the last length and do the perimeter, right? MN is 8, AC 16, MB divided by 10 like that. Understandable right here. Okay, so multiplying diagonally is going to be essentially 80 equal with 16 MB, so MB is going to be 80 divided by 16, and that will be 5. So you can also do like the simplification like that, and you will get 5. So MB is 5. So I think we can do it better like now. MB divided by AB is going to be equal with BN divided by BC. We know BC, so we can just solve it. I mean, we don't need Pythagorean even right now, so we're just going to solve it. A divided by 16 equal with BN divided by 8. So BN is going to be 64 divided by 16, which is 4. So now we have them all. we're just gonna do 4 plus 5 plus 8, so that is how much? That is 9 plus 8, which is 17. Or not 17, how much is that? Yeah, it's 17. 17 centimeters. Boom. Then there's a problem with the cylinder, 60-degree angle and stuff. I think I'm gonna leave this one for another day. So stream is done for now. Yeah, have a nice day.